In the previous video, I set up automatic toolhead switching on my Ender 3, but without a functional toolhead, it's basically useless. So let's build an extruder toolhead. The extruder is the main part of the machine because after all, it is still a 3D printer. The extruder comes in two big parts, the hot end and the feeder. So the hot end obviously deposits filament onto the print bed and makes things, and then the feeder actually supplies the filament at the right amount and right time. And there are two types of feeders, direct drive and Bowden tube. They both have their pros and cons, but after comparing, I decided to go with a Bowden tube. So this is where the feeder motor is attached to the frame of the printer, and then it connects through a PTFE tube to the hot end. And I chose this because not only will it make the entire toolhead lighter, which is important for fast movement, it also takes up less space on the toolhead, which is very important because each toolhead needs to be less than 31 millimeters wide. So this is the filament feeder, and this part is a lot more wobbly than I hoped it would be. So this is supposed to hold up filament, and a small spool seems to do fine. Yeah, I don't trust this with a big spool. Oh, I just heard some cracks, so yeah, I'm gonna have to make this out of a stronger material. But other than that, the feeder is basically done. I just have to connect up the PTFE tubing, and then it should be all good. Another problem with this is the wiring, as this wire, which is supposed to connect to the feeder motor, is attached to this thing which moves along the z-axis. I need to separate it. So this is the extruder, and there are some things that need to be worked on, like there's a screw that's in the way of the hot end right here, so that's a problem. The fan duct mounting is not ideal, and most importantly, these fan wires, these have terminations on them. I had to buy new fans because I needed smaller fans, and the old ones they have no termination on them. They're just attached directly, which is a problem. So I think I'm gonna have to put a termination on it in order to connect it up. I don't think that should be too hard, but it's just some extra stuff, and I don't like doing extra stuff. So I got the toolhead mounted onto the machine, and I did make a new version which has some minor modifications, just separating the extruder, the hot end, from the base plate just a bit more so it doesn't bump into that screw, and also I made a larger hole for this fan because it was being blocked. But there is a problem with this, and that is it's 100% plastic, and considering that this part can melt plastic, that might be a problem. So right now I'm just gonna run the hot end at probably like 210 degrees for a couple minutes and see if anything melts. Of course this wouldn't be a complete video without something going terribly wrong. I tried heating it up to just 50 degrees, nothing too much, and it did not get hot. The thermistor said it wasn't getting hot, and it went into thermal runaway. So I tried replacing the thermistor, or at least reseating it, and in the process the thermistor broke, so now I have to replace it. And I'm thinking it's not the thermistor because when I went to touch the hot end to replace it, it was not hot at all, so this brings us bigger problems. So I flashed the stock firmware onto the printer, and it seems to work now. I turned it off because it was all in Chinese, and right now I'm just flashing the English version of it, so I'll do some tests on it now. So it's able to maintain 60 degrees. That's not much, and that's not what it will be operating at. I just set it to 110 degrees, it's at 90 right now, and everything seems fine. I did notice some warping on the base plate, but I believe that is from tightening the screws too much, because I did notice the warping beforehand, so maybe this amplified it, maybe it was that much warped. Hopefully it doesn't get out of hand once we go up to the 200s of degrees. I have some amazing news. It is able to maintain 160 degrees, which is like the super low end of the PLA melting point, but it can, like, let me show you, let me bring the camera closer. So I can take a piece of PLA and it actually melts. Yeah, this is a bad piece. Let me get a better piece to demonstrate. But now it's time for the real challenge of 215 degrees Celsius. This is my preferred printing temperature on my other printer, and it's the same material, basically same hot end, so let's see if anything will fall apart. So it's at a comfortable 220 degrees, or no, 215, same thing. And I don't see any visible deformations, although it does smell bad. I think that's just how it smells usually. Yeah, it's not visibly deforming, so I'm gonna try manually just pushing through some filament, because the feeder, like, in order to connect the feeder I need the PTFE tube, and the tube is too short and I can't remove it. I'm gonna need another hand, so I'll just push it through manually for now. I am so happy that it works. Not only because it works, we can extrude filament, it gets hot and stuff, but also because the assembly doesn't melt under the heat, because if it does melt, we're gonna have to make it out of metal, and that's gonna make this machine really expensive. And I'm not sure if I've said it in a previous video, but I'm trying to keep the budget of this machine down to just $800. And this is one step to getting to sub $800. So the printer is ready, it's all tuned up, I leveled it, I calibrated the home offsets, all that stuff, and most importantly I put in the PTFE tube that goes to the feeder motor. So I say let's go print something on here. I'll start by printing a simple G-code file that just puts little lines around the bed to test the bed leveling. So the bed leveling was absolutely messed up, and that is kind of my fault, but at least it printed something. I'm gonna try and fix the bed leveling and do that again. So I got the bed leveling better, it's still not perfect. However, there is some weird pattern where there's like, the nozzle goes down into the bed, and it's not because my bed is warped or anything. It's because the entire tool head is going like up and down because there's too much of a tolerance on the mounting system. So yeah, I'm back working on the mounting system. I don't think it should be too much of an issue. However, it's better to just fix it. Also, the spool holder looks like it's about to break off any moment if I put even a slightly heavier spool on it. But for now, I call that a success. So that is the end of this video. Make sure to leave a like, and stay tuned for the next video, or the next few videos really. These are probably going to be the most interesting videos of the series. So don't forget to subscribe with notifications, and I'll see you all next time.